Welcome back to Tarek Podcast. Glad to have you all with us again. Ready for another deep dive into some seriously cool science? This time, we're tackling alien oceans.
You got it. And get this, we aren't talking about some far-off galaxy. We're talking alien oceans right here in our solar system.
I know, right? It's pretty amazing.
Yeah.
Today, we'll be exploring these incredible ocean worlds, focusing on moons like Europa and Enceladus. You know, those moons that might just have massive oceans hidden under their icy shells. And to help us navigate all this, we're turning to a fantastic source, an interview on StarTalk with Kevin Hand. He's a planetary scientist, deep into these ocean worlds, and a key player in NASA's Europa Clipper mission. So get ready to dive into the science behind these hidden oceans. We'll find out why scientists think they could be teeming with life and what challenges and surprises might be waiting for us.
And what's really interesting is how these moons are making us rethink what habitable even means.
Totally. We always hear about planets in that Goldilocks zone, right?
Yeah.
Not too hot, not too cold, just right for liquid water.
Exactly. But these ocean worlds are showing us that there might be other ways for a world to be habitable. These moons might be far from the sun's warmth, but they could be getting enough energy from the gravitational pull of their giant host planets, Jupiter and Saturn. Kind of like a cosmic tug-of-war that's creating heat inside these moons.
Wow, that's pretty wild. So basically, we're talking about a whole new category of potentially habitable worlds. It's not just sci-fi anymore, it's real science.
Absolutely. And the implications are huge. It could mean that the chances for life out there are way bigger than we ever imagined.
Before we get too far, a quick reminder to our listeners, subscribe to our channel Tarek Podcast High. We've got more exciting deep dives coming your way, so hit that subscribe button to join us.
Now, we've mentioned Europa a few times. This moon has captured imaginations for years, showing up in sci-fi and movies like 2010, The Year We Make Contact. What makes Europa such a prime candidate in the search for alien life?
Yeah, Europa seems like it's at the top of the list for a lot of scientists. What is it about this moon that makes it so special?
Well, Europa seems to have all the right stuff for life as we know it. We're talking a global ocean that could have twice as much water as all the oceans on Earth combined. And it's not just some still water either, it's probably interacting with a rocky seafloor, maybe providing those essential building blocks for life.
Okay, so we have water, maybe the right ingredients, and we know there's an energy source from those tidal forces. Sounds promising. But how do we actually study an ocean that's buried under miles of ice?
That's where the Europa Clipper mission comes in. It's not going to land on Europa, but it's going to make some super close flybys. We're talking just 25 kilometers above the surface. To give you an idea, that's closer than some commercial airplanes fly. During these flybys, Clipper will be using all sorts of high-tech instruments to collect information about Europa's ocean.
This is where it gets really cool. If we're not landing, how are we going to study the ocean?
Clipper is loaded with amazing technology. It will have cameras for super high-res images, spectrometers to analyze the surface ice, and even ice-penetrating radar to map the icy shell. Maybe even find lakes beneath the surface. And here's the awesome part. It's got these mass spectrometers that can basically taste anything erupting from the surface. You know, like plumes.
Hold on, we've got to give our Tarek Podcast listeners a quick commercial break. Stick with us, we'll be right back.
And when we come back, we'll delve deeper into how Clipper's going to do all this and why those plumes are so important. Stay tuned.
And we're back on Tarek Podcast. Before the break, we were talking about how the Europa Clipper is going to use these amazing tools to study Europa's hidden ocean, like having a space lab orbiting Jupiter.
You got it. And one of the most fascinating things is that Clipper can analyze the surface ice, which is always being renewed by stuff from the ocean below. It's like a giant conveyor belt bringing us ocean samples without having to drill through miles of ice.
That's so cool. A direct line to the ocean without landing. But I can't help but think about all that radiation around Jupiter, like in that movie, Europa Report, where the radiation is a big problem for the astronauts. Wouldn't that be a huge worry for future missions, even for Clipper?
You're right to bring that up. Jupiter's radiation belts are intense. They could be dangerous to spacecraft and any human explorers. But the interesting thing is that radiation might actually be helping Europa's habitability.
Hold on, how could radiation, which we think of as harmful, make Europa more habitable? That's kind of blowing my mind.
So the radiation hitting Europa's surface can break apart water molecules and other stuff, creating a mix of chemicals. Like, it can make hydrogen peroxide and oxygen, which could then end up in the ocean. Scientists think this could be a source of energy and nutrients for any life down there.
So it's kind of a double-edged sword. Radiation is dangerous, but it might also create what life needs.
This is wild. It really shows how complex these environments are and how much we still don't know. Speaking of challenging our assumptions, let's talk about Titan.
Titan is definitely an interesting place. It's got those huge lakes and seas on its surface, which is pretty mind-blowing on its own. But here's the thing. Those lakes and seas aren't made of water.
Oh yeah, Titan. Another moon everyone's excited about. It's got those vast lakes and seas. But you seem a little hesitant to call it an ocean world. Why is that?
Well, Titan's surface liquids are made of methane and ethane, hydrocarbons basically. This really challenges how we think about life because life on Earth depends so much on water.
Okay, help me understand this. Why is having methane instead of water such a big deal for life?
The key is that water is what we call polar, while methane is nonpolar. They dissolve different things. Water, being polar, is great at dissolving salts and other charged molecules, which is really important for life on Earth.
Okay, I think I'm getting it. So life on Earth depends on water dissolving these key things. But on Titan, with its methane, those things wouldn't dissolve the same way, maybe making it much harder for life to exist.
Exactly. And that leads to the question, could life as we know it even survive in something non-polar like methane? It's a real puzzle. And this is why, even with all those liquid lakes and seas, I hesitate to call Titan an ocean world in the same way as Europa or Enceladus.
This is a lot to take in. It's pretty remarkable. This is truly mind-blowing stuff. We've been talking about how Titan's methane lakes and seas really make us rethink what we know about life.
What's cool is that Titan pushes us to think bigger, to consider the possibility of life as we don't know it.
You know, it's amazing how much our idea of life has changed over the years. Think about those extremophiles here on Earth, those organisms living in super harsh places we thought nothing could live in, like deep sea vents.
Exactly. And those discoveries really show us that we need to keep an open mind when we're searching for life out there. Life on Earth is incredibly diverse, so who are we to say life on other worlds has to follow the same rules?
So even though it's hard to imagine life in a non-polar solvent like methane, we shouldn't rule it out completely.
Exactly. And it's not just about what dissolves things, there's also the energy question. Life needs energy to, well, live. On Earth, most life gets energy from the sun.
Right, photosynthesis. Plants use sunlight, turn it into energy, and then that energy moves up the food chain.
Yep, but on a place like Titan, which gets way less sunlight than Earth, life would have to find other energy sources. Maybe it could use the energy from reactions between the methane, ethane, and other things in its environment.
Like those hydrothermal vents. Could something similar be happening on Titan, powering life?
That's one idea. Another is that Titan life could use methanogenesis. Some microorganisms on Earth use this to produce methane as part of their metabolism.
So instead of breathing oxygen and releasing carbon dioxide, these Titan life forms could be breathing something else and releasing methane. That's wild.
That's the idea. It might sound strange, but remember, we're talking about a completely different environment with different ingredients and different energy available.
It's crazy to think that life could be so different from what we know. But if we find life on Titan, how would we even recognize it? It could be so alien that we might not even know what we're looking at.
That's a good point. Our current ways of looking for life are based on what we know from Earth. We look for water, organic molecules, and chemical imbalances that suggest life. But if Titan life is based on something completely different, we might miss it entirely.
So what do we do? How do we search for something we might not recognize?
That's why it's important to be open-minded and create new ways of finding life that aren't just focused on Earth. We need to think outside the box and consider what other signs of life might be out there.
This is where it gets tricky, right? We don't want to be so narrow-minded that we miss something amazing, but we need some kind of guide for our search.
Exactly, it's a balance. But I think focusing on the fundamental things we think are essential for all life, no matter its chemistry, is key.
Things like metabolism, reproduction, and the ability to evolve. Are those the universal signs of life we should look for?
Exactly. If we find those, even if they look totally different from what we know, then we might be onto something.
Okay, so let's bring this back to the missions. We talked about the Europa Clipper, which will be studying Europa's ocean in detail. What about Titan? Any missions planned to specifically look for life there? Like, we're sending a Clipper to Europa, or are we sending something like that to Titan?
Well, there was the Cassini-Huygens mission, which orbited Saturn and its moons for over a decade. The Huygens probe actually landed on Titan back in 2005 and sent back incredible pictures and data, giving us our first real look at this mysterious world.
I remember those pictures. It was like landing on another planet. The landscapes were weird but kind of familiar, with rivers, lakes, even rain. but all made of methane and ethane.
Yeah, a major achievement. And while Cassini-Huygens wasn't specifically built to find life, it collected a ton of information about Titan's atmosphere, surface, and structure. Really helpful data for scientists to understand how habitable Titan might be.
So what about future missions? Any in the works that are actually focused on searching for life on Titan?
There's a mission called Dragonfly set to launch in 2027. Dragonfly is a rotorcraft lander, basically a big drone that can fly through Titan's thick atmosphere and explore different parts of the surface.
Wait, a drone on Titan? That's incredible. What's Dragonfly going to do during its mission?
It's going to be revolutionary. Dragonfly can land in multiple spots, take samples, and analyze them for signs of life. It will have instruments to study Titan's atmosphere, what the surface is made of, and even drill down to look for water or signs of past or present life.
Okay, so we have Europa Clipple giving us an amazing look at Europa's ocean. And Dragonfly will be searching for life on Titan's surface and in its atmosphere. Two incredibly ambitious missions pushing the limits of space exploration.
These missions are a huge leap forward in our ability to explore these ocean worlds and search for life beyond Earth. They show how much we're learning about these incredible places and how determined we are to answer one of humanity's biggest questions. Are we alone in the universe?
It's an exciting time to be alive, to see these groundbreaking missions happen. As we wrap up this part of our conversation, I'm wondering, what if we do find life on Europa or Titan? How would that change humanity?
It would be one of the most profound discoveries ever. It would mean we're not alone, that life had popped up in at least 2 places in our solar system. It would change our textbooks, our philosophies, maybe even our religious beliefs.
And our whole understanding of life itself. We'd have to rethink everything we thought we knew about how life begins and evolves.
It would challenge us to think about the true diversity and potential of life in the universe. We'd have to face the possibility that life might be way more common and way stranger than we ever thought.
Wow, a lot to think about. This is heavy stuff. We've been talking about the implications of finding life beyond Earth, and it's clear this would be a huge deal for humanity.
No doubt. And it raises a ton of questions. For example, if we do find life, what kind of life will it be? Will it be simple, single-celled organisms? Or could it be something more complex, maybe even intelligent?
And we're back to Tech Podcast. We've been on quite a journey exploring these alien oceans and the possibility of life beyond Earth. It's been pretty mind-blowing. And as we wrap up this deep dive, I can't help but wonder, what could actually be down there in those hilly depths?
That's the big question, isn't it? Will it be life as we know it, based on DNA, RNA, proteins? Or will it be something totally different, something that changes how we define life?
We've talked about this life as we don't know it idea a few times. Can you give our listeners some examples of what that might look like? Can we even imagine life that's fundamentally different from what we see here on Earth?
It's definitely a challenge to our imaginations. We're so used to thinking about life in terms of our own biology, but we have to remember that life on Earth is just one example. It's a product of the specific conditions on our planet.
So if we found life on, say, Europa, it might not even look like life at first.
Exactly. It might not use DNA as its genetic material. It might not use water as its main solvent. It might not even breathe oxygen.
Okay, let's get specific. What are some other biochemistries that scientists have thought about? What are some ways life could exist that are totally different from what we're used to?
One idea is life based on silicon instead of carbon. Silicon, like carbon, can form complex molecules with lots of different structures.
But isn't silicon much less common than carbon in the universe? Wouldn't that make silicon-based life less likely?
That's true, but it doesn't rule it out completely. Life might find a way to thrive even where certain elements are rare. We're talking about huge timescales and countless worlds. It's possible that somewhere out there, silicon-based life has found a way to exist.
Okay, so silicon-based life, what else?
Another interesting possibility is life that uses ammonia as its main solvent, not water. Ammonia, like water, is a good solvent, and it stays liquid over a wider range of temperatures than water.
So in a really cold world like Titan, ammonia might be a better solvent for life than water.
Exactly. And it's not just about the solvent. We also have to think about the energy source. On Earth, most life gets its energy from the sun, but there are other options.
Like those chemosynthetic organisms around hydrothermal vents, they don't need sunlight at all, right?
Right. They get their energy from chemical reactions. So on a world like Europa, which has a subsurface ocean that's probably heated by tidal forces and volcanic activity, chemosynthesis could be the main way life gets energy.
So we might find life on Europa that doesn't need sunlight at all, getting its energy from chemical reactions deep in the ocean.
It's a real possibility. And it reminds us that life can be incredibly adaptable, finding ways to survive in places we might think of as extreme or even hostile.
This is amazing. The more we learn about the universe, the more we realize how little we know. It's both humbling and exciting.
Couldn't agree more. And that sense of wonder, that drive to explore and understand, is what makes searching for life beyond Earth so fascinating.
As we explore these alien oceans, we're not just searching for life, we're also searching for ourselves, trying to understand our place in the universe, to figure out the mysteries of our own origins.
That's a great way to put it. The search for life beyond Earth is ultimately a search for meaning, a quest to understand who we are and where we come from.
And it's a quest full of wonder, excitement, and the potential for amazing discoveries that could change how we understand the universe and ourselves forever.
It's an incredible journey, and it's one that we're all on together as a species.
Well, Tarek podcast listeners, that brings us to the end of our deep dive into alien oceans. We've explored the science, the technology, the philosophical ideas, and the sheer wonder of searching for life beyond Earth. We've learned about places like Europa and Titan, which might have life as we know it, or maybe life as we don't know it. And we've been reminded that this quest is more than just science. It's a journey of self-discovery, a search for meaning, and it shows the incredible curiosity and ingenuity of humanity. So keep looking up, keep exploring, and keep asking those big questions. And don't forget to subscribe to Tarek Podcast Eye for more exciting deep dives. We'll see you next time.